Hi sir, hi classmates, good evening, Carmel Maizie here. Please bear with my report as I'll be discussing it via this recorded video. I would like to apologize as I cannot be with you in this very hour due to onshore work assignment. So sending my regards to all of you all the way here from France. So anyway, at this point of our group report, you should now be familiar and equipped with various terminologies such as time-constrained project, resource-constrained project, heuristics, and resource utilization. I will be greatly dealing into these terms in the succeeding slides. So at this point, if there are any clarifications or questions about this, please do raise and approach the group so that we can discuss further. Okay, for the outline and guide, I'll be discussing about computer demonstration of resource-constrained scheduling and splitting activities. So upon hearing the word computer demonstration, maybe the first thing that may come into our minds are some sort of automation, computerized, and software. Well, yes, relating it to project management software, we have tons of this, ranging from open source to the ones that comes with license. So just to name some of them, we have MS Project, Trello, Slack, and Basecamp. My hands-on experience with this would be using Trello and MS Project. So feel free to share in the class the tools that you have used so that we could exchange thoughts with the industry's best practices in using PM software. Okay, and just a reminder and a disclaimer per se, software is not managing the project. The software is simply a tool that the project manager uses to view the project from different perspectives and conditions. Okay? So moving forward with my report, and let's have a look on the case study present in the book on page presented in the book on page 264, wherein it deals about EMR or electronic medical reference, wherein it's a guide used by medical technicians and paramedics. So one of the feature and functionality of a PM software is that it can generate reports easily based on the data provided. For instance, in this EMR case study, it provided us this daily hourly demand for design engineers from January 15 to January 23. So we could see that the demand or the peak of its demand is by January 18 and 19, wherein it registered 168 hours, so equivalent to 21 design engineers. So 168 divided by 8, so it's 21 design engineers. But do take note that the case study sets the limitation that there's only design eight design engineers that could work on a daily basis. So that's why plotting this demand against the allocation and over allocation, we will get that this pink portion here, the over allocation needed by this set of demand for design engineers. So thus, if this over-allocation will not be dealt or addressed accordingly, we can face a series of consequences like project delays and substantial additional costs for the project. Okay. By initially plotting the schedule, we arrived that the critical path of the project would be from activity 2, 5, 9, and 13 accordingly. And the finish date would be by Feb 14. So I won't be dealing much with technicalities and computations since a substantial discussion was provided already by Jerwin earlier. So our goal here is to translate the manual computations inherited earlier and apply it to a PM software representation wherein it will give us an array of functionalities, perspectives, and decisions to make. Now, applying the three rules of heuristics, computations, and analysis will now lead us to this enhanced presentation of project network. So take note that the critical path is now activity 2, 3, 9, and 13, with the finish project end date of Feb 26. So from Feb 14, it's now Feb 26. Okay. With the help of PM software such as this one, Gantt chart from a project network can easily be generated. So this is the summary of a project network presented on the previous slide. So this is the Gantt chart for the project network without considering the over allocation. Well, this is the Gantt chart of the project network with consideration of the limited resources. So with this graphical summary, please take note that the slack was minimized. So we now have this minimal slack compared to this long slack. So slack was minimized in consideration of limited resources. So in effect, delaying as well some activities. So this one, delayed for a couple of days means critical path will be changed. So as seen on the project network slide. So take note that if we stick with the original schedule and with over allocation of resources, so the effect one of the prime effect would be delayed in the project, but applying the concepts and theories of heuristics and resource utilization, delayed was reduced. Delayed was reduced without compromising the available resources. So yes, it was delayed. The project is delayed, but we can assure that on each day there is a resources or there is a resource that was utilized accordingly based on the limitations sets per day. So thus the following are the impacts of resource constrained projects. So first is it reduces the delay but reduces flexibility. So it reduces the flexibility since resources must be strictly followed in relation to its limitation. Thus, commitment is a key to this one. Next, increases criticality of events. So increases criticality of events. So it was clearly seen wherein critical path was changed considerably. Next would be increases scheduling complexity. So complexity in the terms that resource constraints are added on top of technical constraints considerations for the project. Next, it may make the traditional critical path no longer meaningful. Yes, changes on the critical path based on the project networks. Next, it can break a sequence of events. So we've seen on the Gantt chart that there were projects or activities that were delayed since we need to maximize the resources. And then lastly, it may cause parallel activities to become sequential and critical activities with slack to become non-critical. Okay, so moving forward, another terminology introduced to us in this chapter is the so-called splitting. So splitting is a scheduling technique used to get a better project schedule and or increase resource utilization. So it involves interrupting the work, then returning the resources to finish the interrupted work. So it is said that it's feasible when startup and shutdown costs are low. So splitting is very straightforward as this representation. So imagine this is the duration of the entire activity. So this entire activity, we have split them to activity A, B, and C. And now, by applying the concept of splitting, we now introduce this concept of shutdown and then startup. So splitting is used for various reasons and decisions by a certain organization. It could be a resource break to increase efficiency. So another would be to have a fresh outlook of idea or perhaps to have an outside eye or perspective. But one thing is for sure, Splitting is not advisable when startup or shutdown costs are high. And then lastly, for interaction and discussion purposes, so please do answer the following in the class. So first is how does resource scheduling reduce flexibility in managing projects? Then second, how does sorry sorry for that. Yan. So first, how does resource scheduling reduce flexibility in managing projects? Then second, give example scenarios when to and when not to use splitting in activities. Then lastly, differentiate time constraint and resource constraint scheduling. Okay, so that's all for my part, and thank you everyone. So have a good evening.